Okay, so this is going to be help for the algebra distance learning packet. This will actually be the first algebra packet that you have received, and you should have received it at some point last week. It is for the algebra students, and it is basically part of what you should know before you go on to your class in high school. There will be another one coming out as well with a little bit more practice on quadratics, but I'm going to do these a little bit different than I do the 8th grade packets, and I'm going to do 1 week at a time. I just feel like you guys should be able to retain a lot more than most students, and we've gone over everything that we've needed to do except for a couple of the 8th grade content standards. So I'll help you guys with that in the next few weeks. So anyway, let's take a look at the algebra distance learning packet. So it says days 1 through 15, but I mean, technically it's like 11 through 26. So anyway, just keep that in mind. All right, so here's the breakdown of the different days. So obviously days 1 through 5, that'll be the first week, which is what I'm going to go through. I'm not going to do everything, and there's a lot of good examples and stuff. So I'm just going to go through the things that I think might have caused some problems or that you've personally asked questions about. So again, you can reach out on Google Classroom. You can leave a comment on this video through Remind, any way that you need to. Have your parents email me, whatever it is. Definitely get in touch. I really want to make sure that you guys are still at least practicing some of the math. I know it's tempting to just kind of hang out and, play video games or whatever, or read. But definitely, keep this stuff fresh in your mind, because as soon as you get to high school, you're going to be responsible for knowing it. So just keep that in mind. Okay. So the first day is expressions and equations, multi-step equations. This whole thing is just an example of the different types of solutions that we can have. And remember, this is just a system of equations. Even though it doesn't look like it, it's just 2 lines on a graph, and we can graph it. And then these special cases like no solution, remember that means 2 parallel lines. And then infinite solutions is when we have 1 line and then we graph the other equation and it turns out it's the exact same line. So that's just, it looks a little bit different when we're solving equations. Okay, so looking through this, this should not be any trouble at all. I mean, you guys are really good at solving equations, but let's just do one that might have some problems, maybe with some negatives, things that we kind of typically overlook. I'm going to do this one right here. All right, so the right side stays as 24, and then the left side stays as 24. The right side, we're going to multiply this. So, there's a negative in front of the x. Just keep in mind that's a 1 there, even though we don't write it. So 6 times negative 1x is negative 6x. And then 6 times negative 3 is negative 18. Okay, and then we're just going to isolate the variable, getting rid of all the numbers on the same side as that variable until we have the variable by itself. So that would make this 0. So on the right side, all we have left is negative 6x. On the left, 8 plus 4 is 12. So that's 42. And then we divide both sides by negative 6. And we get negative 7 equals x. Okay, so we should always check our work. So let's look at this original equation. And we want this right side, all of this, to equal 24 if we substitute negative 7 in for x. So in the parentheses, we have negative x, so it'd be negative 7. We'll just change the sign, and then minus 3. So it'd be 6 times, so this would be 7 minus 3, which is 4. 6 times 4, and that does equal 24. So it works. Okay, so just don't forget. You can always check your work to make sure that it's correct. Okay, so moving on. Magic square, so the directions are there. Obviously, this is not typical content that you're going to have to know. it's just there to kind of break things up. So I'll leave that up to you guys. It's just like a teaser math problem. You can see some different ones in the next packet. Okay, so continuing with multi-step equations. Again, just some examples, pulling information from word problems. So here are some problems. Okay, so the first one, a number is divided by 3, and then 4 is added to the quotient. The result is 8. Find the number. So most of these are just like that, okay? And then the last two have some actual context. So I don't know if it really matters. I'll choose the first one. So a number is divided by 3. A number, so that's our variable. So you could use n, you can use x, and then divide by 3. Okay, we're just going to use a fraction. You could write it as this with the division symbol, but as you know, I typically would write it as a fraction. And then it says 4 is added to the quotient. So this whole fraction is a quotient. So we're going to add 4 to that. And the result is 8. So the result, so after we add it, we will get 8. So what is that original number? Okay, so again, you could probably do some of these in your head, but, showing this algebraically, subtract 4 on both sides. Okay, that would leave us with x over 3 equals 4. And the last step, we're going to multiply both sides by 3. Okay, so inverse operation, originally we were dividing x by 3, so we're going to undo that by multiplying, which would mean this 3 over 3 becomes a 1, so 1x is our goal, that's what we want. So 1x, or just x, equals 4 times 3 is 12. Okay, so just kind of go through this again in your head. A number is divided by 3. Okay, so 12 is our number, so 12 divided by 3, that's 4. And then 4 is added. Okay, so 4 plus 4 is 8, and the result is 8. So it works. So again, check your answers just to make sure. 5 and 6, we have some context. Let's take a look at 5. Angela rented a car for $29.99 a day plus a one-time insurance cost of $5. Her bill was $124.96. For how many days does she rent the car? So this sounds a lot like a linear equation when we used to just graph this information, write an equation, mx plus b. So I'm going to use that because I see things like one-time cost. Okay, so one-time initial value, starting value. What does that remind you of? That should remind you of our y-intercept. And then a day or per day, that's our rate. So this is our slope. Okay, so if I wrote an equation for this, it would be y equals m 29.99 x plus b, and it is positive 5. Okay, so there's our equation. And this will tell us if we know how many days, so x is going to be the days. If we know how many days, then we can figure out the price. But this question is actually asking the opposite. It'll tell us the total amount, which is this, which is y. And then we're asked to find the number of days. So I'm going to take this number that we are given and substitute that for y. Okay, so 124.96 equals 29.99 x plus 5. Okay, so it's very similar to any equation that we've solved. We're going to subtract 5 on both sides. And you notice I'm not just writing it under here, right? It's a subtraction problem, so make sure you're lining it up in its correct place. Okay, and then when we do that, we get on the right 29.99x. On the left, we get 119.96 cents. Okay, of course, you can use a calculator. Check your work, make sure it's right. The last step is divide both sides by 29.99. We're almost $30, right? 29. So forget about the decimals. It's almost $30. On the left side, it's almost 120. What's 120 divided by 30? That's 4. So I'm thinking it's x that x is 4 days. So x equals 4. Okay, but check with the calculator. So 119.96, 119.96 divided by 29.99. And that sure is 4. Okay, so that we're not done. Okay, make sure we answer the question. For how many days did she rent the car? So then she rented the car for 4 days. So that's our actual answer. Not x equals 4, because they didn't even give us x. So that's something we came up with. So yeah, just make sure you're answering the question. Okay. Next one is another just kind of game. I'm going to go ahead and let you work on that. Systems of equations. Okay, so this is what I was mentioning about solving multi-step equations, right? When we actually graph it, this is what it means to have no solution. It's parallel. Infinite is the same solution or same line, and then one solution is what we want, and that is where we have two lines that have an intersection point. Okay, let's take a look at a couple problems. And remember, we have other methods of solving systems. So if you want to be able to check your work, you can use an algebraic method to solve, see if you get the same point. Or you could even use Desmos to graph it and just make sure that your graph looks like the one that you did on paper. When we graph equations, we really would like it to be in the form y equals mx plus b. It makes it easier. And just looking down, number 1 looks good. Number 2, that second equation doesn't look like what we would want. Number 3, same thing with the second equation. And then number 4 looks good. I'm actually going to do number 3, so that will help you with number 2 as well. So that second equation, I'm going to rearrange it so that y is on one side of the equal sign and everything else is on the other side. So looking at this, I don't want that x, so I'm going to subtract x on both sides. I'm just going to rewrite that equation. So I have y equals, and I want to put the x first. So negative, don't forget the negative sign, it goes with the x, negative x plus 1. And I'm just going to write a 1 there, just so I don't forget. Okay, so let's graph that one that we just did. So the first thing we graph is the y-intercept, which is 1. Then our slope is actually negative 1 over 1, and that's our rise over run. So negative means to go down. So we're going to go down 1 over to the right 1, down 1 over to the right, down 1 over, down 1 over 1, down 1 over 1. So our line will go through those points. So then just draw a line as straight as possible. Okay, use a ruler, use the edge of your notebook, whatever you have. Okay, and then the other equation, do an orange. Start with our y-intercept of negative 3. And then I'm going to use that slope, 1 over 3. Okay, so it's positive, so we're going to go up 1 over 3. Up 1 over 3. And then we're going to draw a line through those points. All right, and then our intersection, we can see, and it doesn't say how to answer, but we're just going to answer it as an ordered pair. Okay, so this will be this point here, and so the answer, the solution, is 3 comma negative 2. Or you could say x equals 3 and y equals negative 2. Either way. Okay, so that's it. So number 2, you'll have to rearrange. And just, real quick, we're going to subtract 2x on both sides and just rewrite that one. And then you can use that information to graph that line. So just be careful. Be careful of the negative signs. Think about it. Double check your work. Use Desmos to check. Just make sure that you're not making silly mistakes. Okay. Another challenge. Again, Okay, think about these. If there are any questions, then just reach out, leave a comment, and I can go over it in more detail. But I really do want you to think about some of these things. Okay, day 4. Now we're going to solve systems algebraically. Okay, so no graph. So we have some examples here. And then remember, we have a few different options when we solve algebraically. We have elimination, we have substitution, and then different variations of elimination where we have to maybe multiply one of the equations by a number or by a negative. Are we adding? Are we subtracting? So a lot of things there. So maybe we can do one type of each. I'm going to go with number 1 first. So anytime I see y equals, that's going to kind of push me to using substitution. So I'm going to take all of this and I'm going to bring it down into this equation and replace this y with 2x plus 3. So I'm going to rewrite this second equation. So we have 5x minus 2 times 2x plus 3 equals negative 6. So I just rewrote the second equation, but instead of y, I put in what y equals from the first equation. So now we're just going to simplify this distributive property to get rid of those parentheses and then combine like terms and then solve for x. So we have 5x minus, so negative 2 times positive 2x is negative 4x. Negative 2 times positive 3 is negative 6 equals negative 6. Combine like terms. So our like terms are this 5x and negative 4x. So that leaves me with just x minus 6 equals negative 6. Adding 6 on both sides. So that makes a 0. That's also 0. So what does that mean for y? For x. X equals 0. Okay, so that's okay. It's just a number, right? It doesn't mean that there's no solutions. Okay, it's just x equals 0. All right, so now we're going to take that and we're going to bring it into either the first or the second equation and solve it for y. I'm going to use the first equation because it's going to save us some steps. So I'm going to rewrite that over here. So y equals 2x plus 3. And I'm going to substitute a 0 instead of the x. Okay, so y equals 3. So our solution technically is a ordered pair at 0, 3. That's the point where the two lines would cross if we were to graph them. And again, you should use Desmos, type these in, and then see what they look like, see if they do actually cross at that point. But do the work first, and then check it with Desmos. Let's look at number 3. Okay, so number 3. So this time there's no y equals or x equals, so I'm going to use elimination. But look carefully at these two equations. We see that the x and the y, they're not lined up with the same variable. So don't just add those together and get, something like that. That'd be a very easy mistake to make. So don't do that. Make sure they're all lined up. So I'm going to rewrite it so that everything is lined up as it should. So I'm going to stick with x being first, so negative 7x plus 9y equals negative 13. The negative 9x plus y equals 15. All right, so now looking at this, can we add or subtract those two equations to eliminate one of those variables? Not yet. So it's not a very good problem for this. So we're going to do some other steps before we can add or subtract. If I multiply the second equation by negative 9, let's just multiply by negative 9. Okay, so what's going to happen with this term here? So this would become negative 9y, all right? And then if I add those two equations, then my y variable will be eliminated. So I'm going to rewrite this again after I multiply. So negative 7x plus 9y equals negative 13. Okay, so I have 81x minus 9y equals, and then 9 times 15, negative 9 times 15 is negative 135. Okay, so now I'm going to add these two equations. So I have 81 and negative 7, so I'm combining those. So I'm going to get 74x. Then here's the variables that were eliminated. Okay, that's a 0. So then I have 135. So I have negative 135 and negative 13. So I combine those to get negative 148. Okay, and then the final step, divide both sides by the number in front of the variable. So divide that by 74, and I get x equals negative 2. Okay, so there's our x value. Now we can choose one of the original equations to substitute that in and solve it for y. I'm going to use the first one only because, no, actually I'm going to choose the second one because there's no final step of dividing. There's just a there's no number here. It's just a 1. So that'll save us a step. Okay, so the second equation, negative 9, instead of x, I'm going to put negative 2 plus y equals 15. So negative 9 times negative 2 is positive 18 plus y equals 15. Subtract 18 on both sides. That leaves me with y equals negative 3. All right, and then our ordered pair is negative 2 comma negative 3. So here's one, looks a little messy. So let's see if we did this right. So let's use Desmos. So we have 9y minus 7x. 9y, so type it in exactly as it is, 9y minus 7x equals, and remember, you can get this app for free, or you can just use it on a computer, negative 13. Okay, let me clear this. This is from a problem in the 8th grade math packet. Okay, so there's our line. One of them. Okay, the other one is negative 9x plus y equals 15. Negative 9x plus y equals 15. All right, so there's our two lines on our graph. I'm going to change this. It's kind of hard to see, so I'm going to go from, let's do negative 30 to positive 30. There we go. Easier to see now. Okay, so the point where the two lines cross should be the same as what we found. So negative 2 comma negative 3. Negative 2 comma negative 3. All right, so we did it right. Okay, so again, same kind of thing on the rest. You know, again, check your work with Desmos if you need to. All right, so here's another example problem of linear systems, okay, word problems. So pulling out information to write equations that have two unknowns and then solving using some method to find those two variables. Okay, so here are our problems. All right, maybe I'll do number 1. Okay, so number 1, it says Veronica has been saving dimes and quarters. She has 94 coins in all, and the total value is $19.30. How many dimes and how many quarters does she have? Okay, so we have some information here. So we have two things. We have the amount of money she has, and we have the number of coins. Okay, so it's two different pieces of information, and we're going to use those to write our two equations. So first of all, we need some variables. I'm going to say that lowercase d is going to represent the number of dimes, and q is going to be the number of quarters. So we have two variables. Okay, so the first thing we know is there's 94 coins in all. So think about these variables. D is the number of the dimes, the amount, and Q is the number of quarters. So if I just add those, they should add up to 94. Okay, and then the value of these coins is $19.30. So let's think about that. So how would we figure out, if we just have a bag of coins and a bag of dimes, quarters and dimes, how would we figure out the total value? We would count the number of dimes and multiply it by 10 cents, right? So 0.10 times the number of dimes plus 0.25 or 25 cents times the number of quarters. If we do all that and we add it up, that's going to be the amount of money that we have. And in this case, it's $19.30. Okay, so we have the variables on both sides of or on the same side of the equation. And right now, I don't see any way to use elimination without a little bit of work. So first of all, just to get rid of the decimals, I'm going to multiply the second equation by 100. Okay, and this is not the only way to do it. It's just the first thing I think of. So I'm going to multiply this one by 100. Okay, so then just, thinking about this in my head, what is that going to do for us? It's going to move the decimal 2 places over. So I'm going to get 10D plus 25Q equals 1,930. Okay, so no more decimals. All right, so remember, we want to use elimination. So think about that second equation. It's going to leave me with 10D and 25Q. So looking at that first equation, both of those coefficients are 1. So what if we took and multiplied the first equation by negative 10? So that would give me negative 10D, and the second equation will give me 10D. And if I add those together, the D variable will be eliminated. So let's rewrite this and see how that looks. So we have negative 10D. So remember to multiply the negative 10 times each of the terms. Negative 10Q equals negative 940. Okay, and the second equation, just moving the decimal 2 places over, we have 10D plus 25Q equals 1930. All right, now let's see what we get. We can we can add those two equations, and this would be eliminated. And we would end up with 15Q equals, okay, again, break out the calculator. So 1930 minus 940 is 990. And then divide that by 15. And then we get Q equals 66. Okay, so she had 66 quarters. So using that first equation that we started off with, we know the total number of coins has to be 94. So if we take 94 and subtract 66 from it, we get 28. So the number of dimes equals 28. Okay, so just again, maybe in your head, let's see if this works. So take 28 times 0.1, that's $2.80, and 66 times 0.25, and what does that give us? $16.50. So if I add 1650 and 280, I get 1930. So it works. Okay, we're good. So there's our two answers. So again, a sentence would be better. So she has 28 dimes and 66 quarters. So that's our answer right there. Again, it takes time, right? So I think the hardest part is just to figure out which information goes with which equation. So again, try these. If there's any problems, reach out on Google Classroom. Some of you have already, or Remind, or again, parents can email. you can actually email with your iCloud account. Some of you have done that. So yeah, there's lots of ways to get a hold of me. Okay, again, patterns, we've done lots of these. And then we're going to stop here. This will be the next video.